Okay, Assalamualaikum. So next example 9, the vacuum parallel capacitor has plate area is 150 cm square and separation by distance. The capacitor is charged to the potential difference of V0 2000 volt, and then battery is disconnected. After that, the dielectric sheet of the same area placed between the plate and shown in figure. After insert the dielectric, the potential difference across the plate is reduced by 500 volt. The case is disconnected. So in this case, Q is constant. Remember that? Okay, the first question asks you that the initial capacitance of the capacitor. So initial capacitance is C naught is equal to epsilon naught A over D. So 8.85 times 10 to the power of negative 12 times with 150 times 10 to the power of negative 4 meter square divided by D is 2 times 10 to the power of negative 3. So the answer that you get is 6.63 times 10 to the power of negative 11 farad. Okay, next question is charge on each plate before the dielectric is inserted. So Q naught is equal to C naught V naught. Okay, so C is 6.63 times 10 to the power of negative 11 times with 2000. Initially V naught before insert dielectric is 2000. So Q naught will be 1.33 times 10 to the power of negative 7 coulomb. Okay, so next the capacitance after dielectric in place. So new capacitance after dielectric in place is C yang baru. Nak cari C yang baru, jadi QU sama. Q not sama dengan Q. Q yang baru, Q equal to CV. So Q ni adalah sama juga dengan Q naught lah sebab Q kita adalah constant. So 1.33 kali 10 negatif 7. C V yang baru adalah 500 bila kita insert dielectric. So C kita adalah 2.66 times 10 to the power of negative 10 farad. So next is relative permittivity. So relative permittivity is epsilon R. Okay, epsilon R is equal to C over C naught. So C is yang baru 2.66 times 10 to the power of negative 10 divided by the capacitor yang lama. So 6.63 times 10 to the power of negative 11. So we get 4.01 with no unit lah sebab relative permittivity adalah dimensionless unit. Okay, so next is permittivity of the dielectric material is epsilon. So epsilon is equal to epsilon naught times epsilon R. Okay, so epsilon naught is 8.85 times 10 to the power of negative 12 times with 4.01. So you will get 3.55 times 10 to the power of negative 11. Unit is C2 N negative 1 M negative 2. Okay. Next is initial electric field. So initial electric field E naught is equal to V naught over D. So V naught is 2000 divided by D is 2 times 10 to the power of negative 3. So you will get 1.0 times 10 to the power of 6 volt per meter. And then the dielectric, last question. The electric field after the dielectric is inserted. So you can compare by using epsilon R is equal to E naught over E. 1 times 10 to the power of 6 divided by E. So ER, as you know that ER is 4.01. Okay, so you will get E is equal to 2.49 times 10 to the power of 5 Vm negative 1. Okay.